Greetings, math fans. All right, so this is our new chapter. This is chapter 3, and actually it's part A. We're going to break this up into two parts, chapter 3A and 3B. All right, so day 1. What we're going to do is actually a pretty significant day. We're going to talk about derivatives. Okay, so I want to recall something. I want you guys to remember. The slope of a tangent line at a point is basically the limit as h approaches 0 of f of a plus h minus f of a all over h. And remember that's where I say where x equals some value a. Okay? And you plug it in. Well, basically what we're going to do now is we're going to, instead of actually finding the slope of a tangent line, what we're going to do is we're going to find a function for that slope. Okay? Because before, again, you just had a point, right? And I would just basically gave you had to figure out just one value. Well, now I'm going to give you a whole function. I'm going to say, hey, could you find the slope of this tangent line at any value on this function? All right, so let me just write this out here. Now we are going to find a function for the slope of a tangent line. Okay, and this is called the derivative. Okay, there's your key word. This is called the derivative. Okay, so let me just cursor down here a little bit. So this is the definition of derivative. So again, this is going to be a function. Okay, so we call this f prime of x. Now there are a lot of ways to actually the notations, a lot of ways to write this. You see f prime of x. We'll talk about that in a little bit of different notations, but let me just give you the definition here now. So f prime of x is the limit as h approaches 0. So it's kind of the same thing, math fans. And really, again, watch this. Instead of a, because remember x is a value at that point, now instead of putting a value of a, I'm just going to actually put the variable in there because I want a function. So it's x plus h minus f of x all over h. Okay? This is the definition of the derivative. This is huge. Okay, so I'm going to put some stars next to it. In fact, I'm going to change the color of this. Well, maybe not. Okay, and put some stars in the corner here. Okay, the reason this is so important is we're going to learn a couple different ways to do this to find the derivative. But on an AP exam, when they tell you using the definition of a derivative, find the derivative, you have to use limits. Okay, you've got to use limits. Very, very important. Okay, so just kind of keep that in mind. But that is a very, very important formula here with the limit. Again, it's the same thing as we used before, except now we're using a variable instead of a value of a constant value. Okay, all right. Let's talk about some other notation here. Again, we have f prime of x, and this is actually used pretty often here. We use y prime, which is used occasionally too, but then we have something called d by dx, and this is the derivative with respect to x. That's used often. This is actually a very common one too, dy dx. So if I gave you a function, basically if I say y is equal to 2x plus 3, and I ask you to find dy dx, that's really used quite often. This is the derivative of y with respect to x. Okay, because you might have multiple variables in there and you don't know what to take the derivative of, and this tells you that you're taking it with respect to x. So that's the actual function that you're going to be taking the derivative of, even if you have some other variable in there. So this is really used quite often here. Dy, we say, and the way we say it is dy by dx, dy by dx, and this guy right here is d by dx. That's just kind of the English wording. Okay. All right. So let's actually use our nice little friendly derivative definition of the derivative here. And here's your first example. This is very exciting. Find the derivative. And your function is f of x is equal to 2x squared minus 3. All right. Now, I want you guys to notice just a real quick sketch here, right? Do you guys know it's roughly right down 3 and it opens up, and so the graph looks something like this. Rough sketch, okay? So basically what I'm going to do is I want to find a function where I can go to any point on this graph and I can find the slope of a tangent line. Okay, so like here, right, what is the slope of this tangent line here, etc. Okay? So let's use our definition. So f prime of x is equal to 2, and remember we're putting into here x plus h. Okay, so it's 2x plus h squared minus 3 minus f of x. So minus, and then really f of x is actually easy, math fans, because it's just putting an x into there. Well, it's already has an x, right? So it's 2x squared minus 3. That's pretty easy, all over h. Okay, now you know this is like the only calculus they did do here. Writing the definition of the derivative. The rest of it is truly is algebra. Okay, so you just got to be careful. Make sure you square things correctly, subtract things, distribute negatives. Make sure you're really, really careful. So let me show a little bit of work here as opposed to just doing everything in one shot. So 2x squared plus 2xh plus h squared minus 3 minus 2x squared plus 3 all over h. So f prime of x, we had 2x squared plus 4xh plus 2h squared minus 3 minus 2x squared plus 3 all over h. And remember, math fans, another important thing that you're doing here is we're trying to get rid of that h off the denominator, right? So we're trying to manipulate the top to do that. So we get the 2x squareds cancel, the 3's cancel, and we wind up with 4xh plus 2h squared, which of course what we can do is factor out an h. That's very nice. So 4x plus 2h over h. They cancel, and now I can do direct substitution. So that's equal to 4x plus 2 times 0 is equal to 4x. Okay, so that is my derivative, f prime of x equals 4x. Now this is really a handy little function here, math fans. I can plug in any value into that f prime of x, and I can find the slope of my original function, f of x equals 2x squared minus 3. Okay, so if I just to kind of show you this point right here, what's the slope of that tangent line? Well, isn't it 0? Isn't that slope of that tangent line 0? So if I plug in f prime of 0, well, sure it is. 4 times 0, that's 0. Okay, and I can pick any value I want on there, right? Think about it. As x gets larger, so this one point that I put here originally, right? Let's just say that's 2. As x gets larger, more positive, f prime of 2. Okay, what happens to that? Well, isn't it 4 times 2 is equal to 8? So slope is 8. And as it gets larger, if I do f prime of 5, isn't it 4 times 5, which is 20? Well, sure, because my slope is getting bigger and bigger and bigger and bigger. or more steep, right? Okay, so that's kind of handy as opposed to before. I was only able to come up with one value and you to take the derivative. Now I can give you any value I want. I can give you, if it's of course, if I give you negative value, right? If it's something like -2, it's a negative slope. All right, so hopefully that makes sense to you guys. All right, real quickly here, we have our derivative, but my question is find the equation. Okay, that's an important word. Don't, if I ask you for just the derivative, you just give me f prime of x equals 4x. But if I say find the equation of the tangent line for f of x equals 2x squared minus 3 at x equals 3. Okay, well, again, we know f prime of x, and we know our coordinates. So here, let me write this out here. We need two things. We need the slope, and we need an x and y coordinate. Right? That's what the deal is, right? That's what we need for an equation. So our slope, of course, is f prime of 3. That's the slope of the tangent line, and that's just equal to 4 times 3, which is 12. And we need an x and y coordinate. Well, x equals 3, so how do you find y? This is really key, math fans. In order to find y, so to find y, this is important. So I'm going to put a red star next to this guy. To find y, plug x back into original equation. That's so huge, math fans, because the mistakes that people make is they plug it back into the f prime to get the y coordinate. That doesn't make sense. The f prime represents the slope of the tangent line. It doesn't represent the original function. So you've got to plug in 3 into the original equation, which is, so it's f of 3 is equal to 2 times, then it's 3 squared minus 3. So that's 18 minus 3, which is 18 minus 3 is 15. So that's my coordinate. It's now 3 comma 15. Very, very important. Okay, so we're good to go here. The tangent line. Well, of course, we're going to use point slope form. So it's y minus 15 is equal to our slope, which is 12 times x minus 3. That's it, math fans. That's so easy to do that. Please do not put it in slope-intercept form. All right, because you're doing all kinds of extra work, and if you make a mistake and you get it wrong on the AP exam, they take a point off. But if you leave in point slope form, which is the best form to leave it in, you can't make a mistake, or it's pretty tough to. Okay, and real quickly here, if I ask you for instead of the tangent line, if I ask you for the normal line, okay, that's what makes this so nice. Is if I ask you for the normal line, the only thing you're going to do is change the slope. So it's y minus 15 equals, remember it's opposite reciprocal, so negative 1/12 times x minus 3. Okay? It's pretty easy, right, math fans? All right. Real quickly, for tonight's homework, you're going to use the definition of the derivative. Okay, they asked you to use a different form, a couple different things there. I want you guys to actually find the derivative using the definition of the derivative, what we just learned here now. Okay? All right, here's one more example, which I think is important. It's a good example. If you're given f of negative 1 equals 3, and you're given f prime of negative 1 equals 7. I want you to find the equation of the tangent and normal lines at x equals -1. Okay, so find the equation of the tangent and normal lines at x equals -1. Okay, this is really easy. You're given totally enough information here. You have to realize that. First of all, you are given, here's your solution. Since you're given f prime of -1 is 3, isn't that a coordinate? Right? That's saying -1, 3. There's a coordinate. And what does f prime of -1 equal 7? That means at -1, the slope of the tangent line is 7. So my slope is 7. That's it, math fans. You got everything, man. Totally have everything. So, of course, here's your tangent line. It's y minus 3 is equal to 7 times x plus 1. Really, really easy. And, of course, your normal line is going to be y minus 3 equals -1/7 times x plus 1. That's it. Okay? So that's basically the main thing we learned here, super important, is the definition of the derivative is your limit as h approaches 0 of f of x plus h minus f of x all over h. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.